In this video, we're going to use an exponential function to model something in a context, in this case, a bouncing ball. And we're going to try to use multiple representations, so we're going to see a table and an equation, and of course we could make a graph from the table. So the context, you're tracking the height measured in centimeters of a ball bouncing, and the ball has a rebound ratio, where each bounce is a fraction of the previous bounce height. And we need to find the missing values in the table. Okay, so using our previous knowledge about something like this, we just saw in previous videos of how there's a multiplier in these tables. So I'm going to multiply by something to get here. And I'm going to multiply by something, and it's going to be the same number. That's this rebound ratio in this context. So if I want to know 64 times something is 51.2, I can find the multiplier by dividing. So I could take 51.2 divided by 64, kind of run it backwards, and I get 0.8. So I can see that I'm actually multiplying by 0.8. So I'm going to erase my question mark and make that become 0.8. So this is times 0.8, 0.8. So whatever this is, it's times 0.8 and so on, all the way down the table. So if I want to go up the table, I divide by 0.8. So 64 divided by 0.8, and I make it to 80. And then I'm going to do divided by 0.8, and I go up to 80, to 100, to 125. So this was 80, to 100, to 125, just continuing to divide by 0.8 as I go up the table, and I would multiply by 0.8 as I go down the table. So at what height was the ball first dropped? That's the original, before I even dropped it, that would be 125 centimeters. And the rebound ratio is this multiplier. It continually bounces up to 80% of the previous height. So 0.8 is this rebound ratio. Okay, and writing an equation, it's going to look like this. Y equals a b to the x, where this is kind of like the start, and this is the multiplier. So in context, this is the original height that it was dropped from, and this is the rebound ratio. So writing this to an equation, we have the two pieces up here. I started dropping it from 125 centimeters, and I continually multiply by 0.8 x times to make it to the x bounce, like the fifth bounce. So that's my equation. 125 times 0.8 raised to the x power, because repeated multiplication of 0.8 is an exponent.